Today we'll be talking about applications of power series. First one being the use of power series to find limits. Also to notice that the problems that were assigned for the previous section, I could see that only 2 students opened it and only 1 person actually solved some problems. That's not good news at all, because with this topic coming, you will be behind. And next week, the test coming after that, there will be problems. So you need to complete the assignments as we go, perhaps to know what is going on in class. It's not enough to just connect to the class and see what is going on. You need to complete the work. If we have something like in this problem, where we need to use the series to evaluate the limit as x goes to infinity, to 0 of e to the x minus 1 over 10 to the over 10x. When you try to plug in x equals 0, what you see is you get e to the 0, 1, 1 minus 1, 0, and 10x is also 0. So you get 0 over 0. So technically, what you would do in previous classes would be to use L'Hopital's rule to find this limit. But in this class, after seeing that we can represent a function by means of a power series, we will, in this class, ask you to find limits using the power series. So you find the power series of the functions that are involved, you plug them in, and you see what the limit is equal to. In this case, e to the x minus 1 is the numerator. The denominator is 10x. It's already a power of x, so there's no problem with that. The numerator is e to the x minus 1. So we want to represent that numerator as a power series as well. So how to answer this question? This is what you do. So you represent e to the x as a power series. Last time, we saw that e to the x, and you need to know these series when you're answering the question. We said we found that e to the x was sum k from 0 to infinity, x to the power k over k factorial. This is the power series of e to the x that we found. And we found out also that this is true for any x. And so this can be written as 1 plus x squared over 2 plus x cubed over 6 plus and so on. Which means that e to the x minus 1 is x plus x squared over 2, x cubed over 6, and so on. Technically, you don't need to write all these terms. You just need to write enough terms to be able to simplify when you plug them in there. And so now, after finding the power series representation of that numerator, e to the x minus 1, I plug it into the limit there. So that's limit as x goes to 0 of e to the x minus 1 over 10x equals limit as x goes to 0 of x plus x squared over 2 plus x cubed over 6 and so on over 10x. And you can see that these terms can simplify down to x over 10x is 1 over 10 plus x squared over 2 divided by 10x, that's x over 20. X cubed over 6 divided by 10x, that's going to be x squared over 60, and so on. And then you notice that all the terms that are coming after this number are powers of x. And when x goes to 0, all those numbers are zeros because 0 to any power is 0. So everything that comes after that first term, when you plug in x equals 0, you get 0. So the whole limit is going to be equal to 110. So that's the procedure. That's how you use power series to find the limit of a function. Get the Taylor series of each of the functions that is involved, plug them in, and then simplify and take the limit. Now let's look at problem number 2 that is related to that one. Let's say we have U series to evaluate limit as x goes to 0 of e to the, let's say 2x minus 1 plus 2x over 5x squared. So you have a limit like this, and you look at the numerator, you can see that the numerator has e to the x, okay? So that's not a power of x, so you can write that as a power series. The denominator is 5x squared, so that's already a power of x. So all you need is to get the power series of e to the 2x and then subtract 1 plus 2x and then plug them in here and divide. So how do we do this? We got to find e to the 2x, power series of e to the 2x. That's the first thing to do. So you help me looking at the answer we just wrote for the previous one. What would be the power series of e to the 2x? Nicholas?
Would it be 2x to the k over k factorial?
And then what are you forgetting there?
The sum of it from k equals 0 to infinity.
Correct. So it's a power series sum k from 0 to infinity of 2x to the k over k factorial. So it's the same as the power series of e to the x. You just replace x by 2x. And now you write that down. What would this be? When k is 0, 2x to the power 0 is 1. Factorial 0 by definition is 1. Plus 2x to the power 1, that's 2x, divided by factorial 1 is 1, plus 2x squared, that'll be 4x squared, over factorial 2, which is 2, plus 2x cubed, that is going to be 8x cubed, over factorial 3, which is 6, and so on. So that's what e to the 2x is equal to. And now we want to get e to the 2x minus 1 plus 2x out. And then you can see that this is right here, the thing you're subtracting. So you have e to the 2x minus 1 plus 2x equals, and then here you can divide, you get 2x squared plus 4/3 x cubed, and so on. And now you can take it into that limit. And you have limit as x goes to 0, e to the 2x minus 1 plus 2x over 5x squared equals limit as x goes to 0 of, and then you plug in this thing that you just found. So that's 2x squared plus 4/3 x cubed plus over 5x squared. And when you do this, you get limit as x goes to 0. You divide, so that's 2x squared over 5x squared, that's 2/5, plus 4/3 x cubed over 5x squared, that is 415 x plus, and so on. And you can see everything that comes after 2/5 here is powers of x. And when x goes to 0, that whole thing goes to 0 because it is powers of x go to as just zeros, sum of zeros, that's 0. So the limit is equal in this case to 2/5. Is this making sense? Any questions? Any questions on the topic? Okay, so if no questions, then let me give you this other problem. You get 5 minutes to think about. Limit as x goes to 0 of 2 tangent minus 1 of x minus 2x plus 2/3 x cubed over 3x to the fifth. And I say you can use your notes from the previous lectures to find out what is tangent minus 1 over x. What's the power series of tangent minus 1 over x? Anyone ready to share something?
I can share.
All right, so what is your tangent minus 1 of x?
So I had the tangent minus 1 of x as the power series from k equals 0 to infinity, -1 to the k times x to the 2k plus 1 over 2k plus 1.
That's what we had, and I was saying that the difference between this and the power series of sine x is that here you don't have factorial, right? So this is it, and you develop that as what?
As x over 1 plus
That's x,
plus negative x cubed over 3
which is minus x cubed.
Plus x to the 5th over 5.
And then you notice that the denominator here is x to the 5th. So at least here you must reach and pass x to the 5th before you stop, okay? So here you need one more term. What will it be here? It will be a minus, right?
Yeah, minus x to the 7th over 7.
That's it. And then you just put the 3 dots to say it continues. Now notice that this limit you have on top here has a 2, 2, 2, 2 everywhere. So you can actually put this 2/3 out, and it's 2/3 limit as x goes to 0 of tangent minus 1 of x minus x plus 1/3 x cubed. And therefore you can see already my x cubed over 3, you see? So those are the terms that are being subtracted, which are here. So you get tangent minus 1 of x minus x plus x cubed over 3. This is equal to x to the 5th over 5 minus x to the 7 over 7. And then you got the dots. And so you take that into the limit. So you get 2/3 limit as x goes to 0 of x to the 5th over 5 minus x to the 7 over 7 divided by x to the 5th. And I can actually omit the dots now because I already understand that those dots are always going to give me a 0 because I have terms there that are of order higher than 5. And now I can divide this and I get 2/3 limit as x goes to 0. Then that's going to be x to the 5th. When you divide, you get 1/5 minus, here you get 1/7 x squared. And then when you plug in x equals 0, you get 0, 1/5. So the limit is 2/15. Questions? Any question? Mr. Holiday?
Can you show how you got 2/15 again?
That's 2/3 times 1/5.
Oh, okay, thank you.
Mhm. All right, that's what you have about limits and how you find the limit of a function using power series. Now let's try another application here. We have a problem. We have f of x equals x to the power 7. And the first question is A, differentiate the Taylor series about 0 of f of x. And then B, identify the function represented by. So this is one of the type of questions you get on your test. Identify a function that is represented by the power series. Identify the function that is represented by the differentiated series. And then C, give the interval of convergence. Of the differentiated series. So first, you need to differentiate the Taylor series about 0 of f of x. In order to do that, first of all, you need to be able, I'm missing something here, that's sine of x to the power 7. First of all, you need to find the Taylor series of this function before you take a derivative. And then identify the function that is represented by that derivative, that power series of the derivative, and then give the interval of convergence. So answer, first thing, A, you need to find that power series first. What is the power series of this f of x, which is sine of x to the power 7? Can you help, Keshan? Hello?
Yes, you said we're the differentiating sine x to the 7th.
Give me the power series of sine of x to the 7.
Hello, Miracle. I'm glad you're here. Absolutely. And our guest just texted.
So that would be 7x to the 6 times cosine x to the 7th.
I want the power series of sine x to the 7, not the derivative. The power series that represents x to the power sine of x to the power 7.
How are you? Good. Oh, I'm so glad. Miracle, give me a thumbs up if you can see my screen.
-1 to the k times x.
It starts by what?
1 minus x squared over 3 factorial.
Before getting to that, what is the first thing that comes here?
Oh, sigma,
Tom.
summation, yeah.
K from?
0
Mm-hmm.
to infinity.
All right.
-1 to the k
Mm-hmm.
times x to the 2k plus 1.
Not x. You are talking about sine of x to the power 7.
Wait, I'm lost.
We are talking about the sine of x to the power 7. So what goes inside here?
So would it be 14k?
You take the power series of sine x and you plug in x to the power 7 for x. Oh, that's what you get. So now you got to simplify that thing. And it's going to be -1 to the k, x to the power 7 raised to the power 2k. That's x to the power 14k plus 7 divided by 2k plus 1 factorial. That's what you get. And now you're going to take the derivative of that because the question asks to find the derivative. And so f prime of x, and that is going to be sum k from 0 to infinity. This is -1 to the k. So you take the derivative of that, it's going to be 14k plus 7 times x to the 14k plus 6 divided by 2k plus 1 factorial. To take the derivative, all you need to do is to take the derivative of the powers of x that you see. That's why we get this. And that's the answer to the first question. And now you can try to write those terms down. The first few terms, 1, 2, or 3. So when k is 0, -1 to the 0 is 1. When k is 0, this is 7. This is 1. So this is 7x to the 6 minus, when k is 1, that's 14 plus 7, 21. So that's minus 21 over 3 factorial, which is 6x to the power 20, because that'll be 14 plus 6. And then plus the next term is going to be what? K equals 2, so that's plus 2 times 14, that's 28 plus 7. That's 35. And then K is 2, that is 4 plus 1, 5, factorial 5. Let me just put factorial 5, and then x to the power 28 here plus 6, that is 34. So that's what the first term, the first 3 terms of that series are. Any questions? Is there any question? Now the second part of the question says, identify the function that is represented by the differentiated series. So identify the function that is represented by this. And so when that question is asked, you shouldn't just come here and start looking at this function to see what it represents. Remember how you got it. You got this by taking the derivative of f of x. So that function that is represented there is the derivative of f of x. So the series represents f prime of x, which is the derivative of sine of x to the power 7. And that is 7x to the 6. Using the chain rule, derivative of sine is cosine of x to the 7. So the function that is written there is the power series of 7x to the 6th times cosine of x to the 7. Then next question says the interval of convergence. So we know that the interval of convergence or cosine x is negative infinity to infinity. We do know this. And if that's the case, then the interval of convergence, I'm going to continue writing IC for interval of convergence for cosine of x to the 7th is also negative infinity, infinity, because we are just plugging in a power of x. So that interval of convergence is going to remain same. And therefore, multiplying by a power of x, we are not going to change the interval of convergence. And in this way, we answer the question without having to find the radius of convergence and doing the whole work from scratch for this series. Questions? Any questions, please? Now, if there is no question, then I'm going to ask you to answer the same question for f of x equals e to the 2x. Answer these same three questions. Is there any reason why everybody is off camera today except Nikos? So anyone to share his answer? What's your differentiated Taylor series, Eric?
It's the summation to
First, we start by f of x. What is f of x? And in power series.
E. Oh yeah. Okay. Yeah. K to 0
Mm-hmm.
in infinity, and then e to the 2k times x minus 2 over k, and then over k factorial.
Can you say that again? What do
Yeah.
I?
E to the 2k
No.
times x minus 2 to
What
the
are we?
k. Wait, what?
What are we using here? Power series of e to the x. What's the power series of e to the x?
Is it not e to the x over k factorial?
So open the previous lecture.
E to the a? Is,
What's the power series of e to the x centered at 0? We use it in 2 problems already today.
x, it's going to be 2x to the k over k factorial.
Right. Thank you. So that's the power series of e to the x, and you plug in 2x. So you always start by that, and you need to know these power series. Now you plug in 2x because you're talking e to the 2x. And so to make sure you don't mess up, you separate the coefficients and the powers of x. So that's 2 to the k over k factorial x to the k. And now you can take the derivative. F prime of x is sum. And you remember when you take derivatives, the term with 0 can drop out when k comes down. So you can just start k from 1 to infinity, 2 to the k, x to the k minus 1 over k factorial. And then the derivative gives you a k here. And then k over factorial k, this turns into sum k from 1 to infinity, 2 to the k, x to the k minus 1 over k minus 1 factorial. Because k over k factorial is k minus 1 factorial. So you got your derivative. Now B says, what is the function that is represented by this derivative? What's f prime of x? That means on the other side, just give us the derivative of e to the 2x. What is it? What's the derivative of e to the 2x? Engage. Is Gage here? All right, so just his computer is here. Can I have Nicholas, please?
I had 2x e to the 2x for the derivative.
What is that again?
2x times e to the 2x.
Why would you have 2x?
Sorry, would it just be 2 then?
So that's 2e to the 2x. And so that's what that derivative is. And we know that derivative is equal to this sum, k from 1 to infinity, 2 to the k, x to the k minus 1 over k minus 1 factorial. And then you now look for the interval of convergence. I can give it the same way. Interval of convergence of e to the 2x of the, by e to the 2x, but of the series of e to the 2x of e to the x is negative infinity infinity. We established that when we derived the power series, so we know it's negative infinity to infinity. So if we just replace x by 2x, we're not changing this. So interval of convergence for some k equal 1 to infinity, 2 to the k, x to the k minus 1 over k minus 1 factorial, which is equal to 2 e to the 2x, is also negative infinity infinity, because it will not change. We just multiplied x by 2, right? And this works because it's negative infinity infinity. So 2 times infinity is infinity. Infinity divided by 2 is infinity. That's why it works. Otherwise, I would have to take this interval and then go look at what happens on the boundary of the interval. All right? That's why this is enough, just because it's negative infinity infinity. If that was negative 1, 1, I would have to check the boundary to see if I need to include them or not. Am I making sense here? All right. Any questions on this? Is there any question? All right, so let's look at the next thing I have on the agenda for today. If you actually carefully check what we are doing in class and what you ask on your assignments, you realize that all the questions that you're answering on your assignments are actually the questions that I have answered in class, because I use your assignments during the class. And I just do the similar problems that you will do there. And if you just follow that and just watch that video and repeat the things, you shall be fine with this class. What changes from what you do to what I do in class is just the sample functions, because randomly the program gives a different problem to every time you open it. That's the thing. It gives a different function, but of the same question, right? Okay, so now what we are going to do is learn how we can use. So we learned first how to use the power series to find limits, then how to use power series to find the power series representation of a derivative of a function, how to identify the power series when we know that it came from another function, and so on. Now we are going to learn how to use the power series to approximate integrals that we would otherwise not be able to compute. All right, so that's the part 3 of the course, using power series to approximate integrals. And then here I'm going to say use a series to estimate and approximate actually play the same role. The integrals. With an absolute error of magnitude less than 10 to the minus 8. In this class, when you see something like this, you know you got only 2 options. Either it's integral test or it is alternating series, right? When you have estimate with magnitude less than 10 to minus 8, you know we have those 2 things. Now, and here the integral that we are talking about is integral from 0 to 0.3 of 2e to negative x squared dx. Now, when you look at this, you would ask yourself, man, so this is such a simple function. Why do we need power series to do this? And the answer is this integral has no closed form. So you cannot compute this integral to plug in 0 and 0.3. There's no way you can do that. Okay? So we got to go through the power series. And then we look at this function and we see that's e to negative x squared. Quite nice function. We know that it comes from e to the x. Again, e to the x is, what's e to the x again here, Nicholas? That sum k from 0 to infinity of what?
Of x to the k over k factorial.
Good, x to the k over k factorial. So we are going to use that right here. Replace x by negative x squared. So that means e to negative x squared is nothing but sum k from 0 to infinity negative x squared to the k over k factorial. And this is sum k from 0 to infinity negative 1 to the power k. Oh, you see negative 1 to the power k. Whenever you see that coming in, you understand it's what kind of series?
Alternating series.
Alternating series. Great. So that's it right there. And now you understand how you're going to use this information. X to the power 2k over k factorial. So that's the thing. And this is what we are going to take into the integral to replace e to negative 2x. So that's going to be 2. I can put 2 out of this integral. It's not a problem. Integral from 0 to 0.3 of sum k from 0 to infinity negative 1 to the k x to the 2k over k factorial. And we are fine with this because we know that this integral is for all x. This power series is equality is true for all x. So we can plug it in, dx here. And so this is, we can switch the sum and the integral. Negative 1 to the k can stay out, k factorial can stay out, and then integral from 0 to 0.3 of x to the 2k dx. So you're going to compute that integral. And so we can see now integral from 0 to 0.3 of x to the 2k dx is x to the 2k plus 1 over 2k plus 1, and then plug in 0, plug in 0.3. When you plug in 0.3, you get 0.3 to the power 2k plus 1 over 2k plus 1 minus, when you plug in 0, you get 0. And so this is what you put in there to replace the integral. So we have integral from 0 to 0.3 of 2e to negative x squared dx equals sum k from 0 to infinity negative 1 to the k, and then 2 times 0.3 to the 2k plus 1 over 2k plus 1 times k factorial. That's the thing. So this is the power series that we have. And we know that the interval of convergence of this series, this is true for all x. So we know that this series converges. We don't need to prove it because we can derive from the function that was inside the integral that the integral of convergence of this series is going to be that this, no matter what you plug in as x, you're going to have a converging series because the interval of convergence is from negative infinity to infinity, as in the previous two examples that we solved. So this, it converges, it's an alternating series, so we know that the remainder, absolute value of Rn is less than Bn plus 1. And I want this to be less than 10 to minus 8. And that will imply 2 times 0.3 to the 2. N plus 1 divided by 2n plus 1 n factorial has to be less than 10 to negative 8. And so this is what you need to solve. And in this case, as you can see, it's not something that you're gonna solve in quadratics. You need to just plug in the numbers to figure out which one is gonna be the best thing you get. And I think it's not gonna be a large number though. And then you solve this for n. And when you solve for n, you use that n to give this integral approximately for s n, right? In this case, actually, this Sn is going to be from the first term 0 all the way up to an. So it's like Sn plus 1, but we call it just Sn to keep the notation that we use, where an are the terms that you have in here after finding the n from here. And then you add these terms. So we're not going to spend time on that. I'm just showing you that here like this. On this specific example, you will need a calculator to be able to solve for n here and take that n to plug in here to add the first n plus 1 terms, because n plus 1 because the first term of the series is k equals 0, right? Any question? Is there any question? All right, so if there is no question, let's do the same thing for this other question. Repeat the question for f for integral 0 to 0.57 of natural log of 1 plus x squared dx and 10 to minus 3 for the error. So first you tell me what's the power series that you want to use for that.
Would the power series be x squared to the k plus 1 over k plus 1?
Whenever you speak of power series, you need to say what you're adding, sum from what to what.
Sum from 0 to infinity.
And so first we had, let me see. Okay, you can start by saying that you can look at the natural log of 1 plus x as the integral of dx over 1 plus x, right? And that would actually be integral from 0 to x. And the 1 over 1 plus x is nothing but negative x to the k, the sum of negative x to the k. So that's sum k from 0 to infinity. Integral negative 1 to the kx to the k dx, 0 dx, which is from 0 to infinity, negative 1 to the k. The integral of x to the k is x to the k plus 1 over k plus 1. So that's going to be x to the k plus 1 over k plus 1, which can also be written as sum k from 1 to infinity, negative 1 to the k minus 1 x to the k over k. And then you plug in now x squared. You plug in x squared, you get x to the 2k over k. And now, if you want integral from 0 to 0.57 of ln of 1 plus x squared dx, then that's going to be sum, okay, from 1 to infinity, negative 1 to the k minus 1, integral from 0 to 0.57 over k, x to the 2k dx, which is nothing but sum k from 1 to infinity, negative 1 to the k minus 1, 0.57 to the power 2k plus 1 over k times 2k plus 1. That's it. And then you look at absolute value of bn plus 1 less than 10. 10 to the negative 3 in this case, which would mean 0.57 to the power 2 times n plus 1 over n plus 1 times 2 n plus 1 and then you solve for n. All right, that's it. All right, we can stop on this then today. It's gonna be a very hard time for me actually because my brother went missing since Monday and We are in the process of a search. We haven't